Let's talk about complementary and supplementary angles. You might remember from middle school that complementary angles add up to 90 degrees and supplementary angles add up to 180 degrees. But before we get too deep into that, let's talk about some new vocabulary. First, opposite rays. Opposite rays are kind of exactly what they sound like. They're rays that go in opposite directions. The important thing is they have to share an endpoint. Another way to think about it is that you can have three collinear points, and the rays extend from the point that is between the other two. So in this diagram, ray AR, which starts at point A and heads to the left towards point R and beyond, and ray AY, which starts at also point A and then extends to the right towards point Y and beyond, those two rays are opposite rays. The 3 points R, A, and Y are collinear. The two rays share an endpoint of A, and they head in opposite directions. Another new vocabulary word that we're going to need to know is the word adjacent. If two angles are adjacent, that means that they share a vertex, and they share one side. Basically, adjacent is another word for touching or next to. So for example, in this diagram, angle ABD, which is the purple angle, it's adjacent to angle DBE, the blue angle. The reason for that is because they share side BD, as well as vertex B. However, that purple angle, angle ABD, is non-adjacent to angle EBC, the orange angle. They share vertex B, but that's it. They don't share any of their sides. The sides of the purple angle, ABD, are BA and BD. But the sides of the orange angle are different. They're ray BE and ray BC. Therefore, purple and blue are adjacent, and purple and orange are non-adjacent in this diagram. Let's try an example. I want you to name an angle that is adjacent to angle SQT, which I have highlighted in orange. Do you see any? I actually see two. I see angle PQS. Those two angles, the orange one and the purple one, share ray QS as one of their sides. That makes them adjacent. And I also see that angle SQT is adjacent to angle TQR. The orange angle and the blue angle share side QT, therefore they're adjacent. They're next to each other. But let's flip it around. This time I want you to tell me an angle that is non-adjacent to that blue angle, angle TQR. For this, there's only one answer, and that's the purple angle, PQS. These two angles are non-adjacent to each other because they don't share any sides. Now that we know the difference between adjacent and non-adjacent angles, let's talk about how that applies to complementary and supplementary angles. As I said earlier, complementary angles have to add up to 90 degrees. However, they may be adjacent or non-adjacent. The classic diagram for complementary angles looks like this one, that I have two angles that basically add up to a right angle. So angle ABD is 70, angle DBC is 20, 70 plus 20 gives me 90, angle ABC is 90. But it doesn't have to be that way. You don't have to look for a right angle in order to find complementary angles. You could have completely non-adjacent angles like these two. Angle XYZ is 31 degrees, angle UVW is 59. 31 and 59 gives me 90, so these are complementary angles as well. And it's the same idea for supplementary angles, except they add up to 180 degrees instead of 90. But just like complementary angles, they may or may not be adjacent. You might be used to seeing diagrams that look like this. That's basically a straight line with a ray coming off of it, and those two angles add up to 180, because angle EFG was a straight angle, which means it measures 180. This is certainly one possibility to find a supplementary angle, but it's not the only possibility. You could also have a diagram that looks like this. Two non-adjacent angles, angle RST and angle PNM, they add up to 180 as well, which means they're supplementary. So let's use this information to calculate some missing angle measures. I want us to calculate the measure of angle LJK, given that angle IJL and LJK are complementary. Complementary means that they add up to 90 degrees, so I can say that 57 plus the measure of angle LJK is equal to 90. So I'll just subtract 57 from both sides, and I find out that the measure of angle LJK is 33 degrees. In our next example, we need to find the measure of angle WXZ, given that WXZ and ZXY are supplementary. So since they're supplementary, that must mean they add up to 180 degrees. So I can say the measure of angle WXZ plus 112 equals 180. Subtract 112 from 180, and I get my answer of 68 degrees. Okay, let's kick it up a notch with some algebra. Same idea, except we're going to have to solve for x first. So since we're told in the instructions that these two angles are complementary, I know I can add these two angles together and set it equal to 90 degrees. So 9x plus 4 plus 3x plus 2 equals 90. Combine like terms, 9 and 3 gives me 12, 4 and 2 gives me 6. Subtract 6 from both sides, divide by 12, and I get an answer of x equals 7. But remember, that's not really your answer, it's more like part of your work, because what we were asked is what are the measures of angle M and Q and the measure of angle Q and P. So I need to take 7 and put it back into x in each of these variable expressions. So I would find out, when I simplify those, that the measure of angle M and Q is 67, and the measure of angle Q and P is 23. After you plug in your value of x, and you get these final answers, you should really double check and make sure that your final answers make sense. And by that I mean, did they add up to 90 degrees? Because they were supposed to, right? They were complementary angles. Well, let's check. Is 67 plus 23 equal to 90? Yep, sure is. So looks like I did it correctly. Our next example also has variable expressions, except this time these angles are supplementary, which is going to mean that they'll add up to 180 degrees instead of just 90. So I can say that 4x minus 7 plus 8x minus 5 is equal to 180. Combine like terms, 4x and 8x gives me 12x, and negative 7 and negative 5 gives me negative 12. Add 12 to both sides, and divide by 12, there's a lot of 12s in this problem, and I get an answer of x equals 16. So I can take 16 and plug it back in here, and here, simplify, and find out that my answers are 57 for the measure of angle STV, and 123 for the measure of angle VTU. And quick double check, those two numbers add up to 180, so it looks like we're good to go. Our next problem is similar to the previous problems, except instead of the diagram being labeled for us, the angle measurements are described to us in reference to each other in the directions. Let's read. The measure of angle ABD's complement is 10 less than 3 times the measure of angle ABD. So calculate the measures of angle ABD and the measure of angle DBC. So, anytime you see this kind of a problem, whether it's in reference to angles or anything else, where it says that something is this many more than whatever times the whatever, call one of the things x, and then call the other thing however it describes it to you. So in this case, it says it's 10 less and 3 times. So in reference to x, I would need to say that it's 10 less and 3 times. In other words, I would say it's 3x, so that's the 3 times part, and minus 10, that's the 10 less part. So one of the angles I called x, and the other angle I'd called 3x minus 10. And since I'm told the word complement, ABD's complement is 10 less than 3 times the measure of angle ABD. Complement means they add up to 90. So I can take these two variable expressions, add them together, and set it equal to 90. Combine like terms, add 10, divide by 4, and I get x equals 25. So that means that the measure of angle ABD is 25 degrees. To figure out the measure of angle DBC, we can plug in 25. 3 times 25 minus 10, that would give me an answer of 65. Our final problem is pretty similar to the previous one, except this time we don't even have a diagram to work with, we just have a description of the angles. It says the measure of an angle's supplement is 15 more than 4 times the measure of the other angle. So the wording of this problem is super similar to the previous one, which means I'm going to need to call one of the angles x, and then the other angle whatever it describes, in this case 15 more and 4 times. And also one other difference between this problem and the previous one is the word supplement instead of complement. So this time we're going to be adding our angles up to 180. So one of my angles I'm going to call x. The other angle I'm going to say is 4x plus 15, because that's 4 times 4x and 15 more, so plus 15. So this is the first angle, plain old x. This is the second angle, 4x plus 15. And I'm adding those two angles together to be 180 degrees because it says that they're supplementary. Combine like terms, subtract 15, divide by 5, so one of the angles measures 33 degrees. The other angle measure, you can plug 33 into your 4x plus 15. Remember, 4x plus 15 was the measure of the second angle, so I can do 4 times 33, then add 15 to it, and get 147. An alternative way of doing that is figuring out what do I add to 33 to get to 180. I would just do 180 minus 33, and that's another way to get to the answer of 147 degrees. That's all you need to know about complementary and supplementary angles. In our next part of this lesson, we'll be describing linear pairs, which is another version of a supplementary angle, as well as vertical angles.